For section 5.4, solving radical equations, I'm actually going to split this up into 2 days. The last few problems take a little longer, and I'm going to give them their own day. So first, for solving radical equations, any radical equation would be any equation that has a radical in it. And remember, radicals could also be written exponentially, so this could have also been, for this example here, 2 times x plus 1 to the 1/2 power equals 4, and that's still considered a radical equation. So what we're going to do to solve them is we're going to get whatever the radical or whatever's being raised to the power on one side of the equation, all right, get everything else to the other side. We're going to raise both sides of the equation to the same exponent. Our goal is to get rid of the radical. So if it's a square root or a power of 1/2, I'm going to square both sides. If it was a cube root, I would raise both sides to the third power. If it was raised to the 1/4 power, I would raise both sides to the 4th power to cancel out that 1/4. And then we're going to solve the rest the way we normally would. It's important here that we're going to check our solutions because sometimes we're going to get some extraneous solutions and we have to make sure that we get rid of those. Our first example, we're going to solve this equation and check our solution. So like we said, we want to get this piece alone. So right now it's being multiplied by 2. To undo that, I could divide both sides by 2. And now I'll have the square root of x plus 1 is equal to 2. Now this is by itself completely, so I can square both sides because squaring is the opposite of a square root. And remember, this symbol is just going to get canceled out with the power, and we're going to be left with whatever expression was inside. So now we have x plus 1 equals, and our 2 squared is 4. And now this is nice, easy to solve. We're going to subtract 1 from both sides, and we get x is 3. All right, remember we said we do want to check our solutions. Oops, didn't mean to cross it out, meant to underline it. So I'm going to plug this x is 3 back in here just to make sure. So that's 2 times square root of 3 plus 1 is equal to 4. So this is 2 times the square root of 4. We know the square root of 4 is really 2, so we get 2 times 2 equals 4. And yes, that does in fact work. So x equals 3 is a good solution. Another example we'll do together here, we have a cube root problem. So again, I want to make sure that this piece is by itself, which means I have to get rid of the -1 first. So I'll start by adding 1. So we're going to get the cube root of 2x minus 9 is equal to, when I add 1, I get 3. We want to get rid of the cube root. So in order to do that, I'm going to raise both sides to the 3rd power. Right? So here we're going to get the expression that was inside. This cancels with this. 2x minus 9 equals 3 to the 3rd power is 27. Again, nice linear equation. We're going to add 9 to both sides. We get 2x is 36. Divide. We get x is 18. Doing a quick check. We're looking at the cube root of 2 times 18 minus 9 minus 1 equals 2. It's going to end up being the cube root of, going to do a little bit of math together, 36 minus 9 is 27. The cube root of 27 is 3. And we do know 3 minus 1 equals 2. So x equals 18 is a good answer. Try that next set of problems. Pause when you're good. Come on back to check. All right, if you're good, number 1, you should have gotten x equals 27. Number 2, you should have gotten x equals 0. And number 3, you should have gotten x equals 11. All right, moving on. We have a word problem here. So we have in a hurricane, the mean or average sustained wind velocity V, and that's represented in meters per second, can be modeled by V of P equals 6.3 times the square root of 1013 minus P. And P is our air pressure in millibars at the center of the hurricane. We want to estimate the air pressure, so we're going to find P at the center of the hurricane when the mean sustained wind velocity, or V, is 54.5. So this is the value we're going to substitute in here. So we're going to have 54.5 equals 6.3 times the square root of 1013 minus P. The goal should be to get the square root alone. So first I'm going to divide both sides by 6.3. Okay. When I do that, I get about 8.65. So now that's equal to the square root of 1013 minus P. We know with this step we're going to square both sides, right? We want to get rid of this square root. So squaring both sides gives me about 74.84 equals 1013 minus P. I can subtract 1013 from both sides. That'll give me negative 938.16 equals negative P. And if I divide both sides by a negative, I get P is 938. We'll round to a whole number. Yeah, we'll round to a whole number. Millibars, right? That's what they told me it was in terms of millibars. And that's our answer for that problem. So the one you're going to try is very similar, same exact equation, but now they're telling you that the sustained wind velocity is 48.3 meters per second. So we're finding that V of P is equal to 48.3, and we're going to find P again. You can go ahead and round that to a whole number. Pause it when you're ready, and unpause when you're done. You should have 954 millibars as your p-value. All right, so in our next example here, we have solve the equation, check your solutions. We have x plus 1 equals the square root of 7x plus 15. So since this square root is already by itself, I know I'm going to get to raise both sides to the second power to get rid of it. But I have to be careful when I raise this side to the second power, right? This is x plus 1 squared, which is really x plus 1 times x plus 1. We have to make sure we FOIL or distribute here. So we're going to do the x times both of those. We're going to do the 1 times both of those. So on the left-hand side, we have x squared plus 2x plus 1. And on the right side, our symbols cancel. And we're just left with 7x plus 15. Now I have a quadratic, and we know in order to solve a quadratic, it should be equal to 0. So I'm going to minus the 7x, and I'm going to minus the 15. That leaves us with x squared minus 5x minus 14 equals 0. All right, this can be solved by factoring. We're looking for what multiplied to negative 14, added to negative 5. That's negative 7 and positive 2. In order to solve this, we're going to set each of these equal to 0. So I end up with x is positive 7 and x is negative 2. And again, check your solutions. If I were to substitute in the 7, we get 7 plus 1 equals the square root of 7 times 7. I'm going to do a little quick math here. 49 plus 15. So this is 8 equals the square root of 64. Right? The square root of 64 is 8. So that works. We know x equals 7 is a solution. Try negative 2. So I'm going to do negative 2 plus 1 equals square root of 7 times negative 2. I'm going to put negative 14 plus 15. So now what I have here is negative 1 equals the square root of positive 1. And we know when we take the square root of positive 1, we're not going to get negative 1. So that does not work. So x does not actually equal negative 2. That's one of our extraneous solutions. So you're going to go ahead and try these next two. Make sure for this one we remember to FOIL because there was nothing to cancel. For 6 can be a little bit easier because our symbols were just canceled on both sides. Do make sure you check your answers, pause when you're ready, and unpause when you're done. For 5, we should have gotten x is 0 and x is 4. Both of them work when they're checked. And for 6, we get x is 2. And that works when it's checked. Our next example here, like I said before, this is still a radical equation. It's technically just raised to a power, a rational exponent. I want to get whatever's being raised to that power by itself before I do anything else. So I'm going to subtract 2 to start. So when I subtract 2, I still have 2x to the 3/4 power, but now it's equal to 8. And what I'm going to do here is I'm going to raise it to the reciprocal power, right? So if I raise this side to the 4/3 power, 4 times 3 is 12, 4 times 3 is 12, 12 over 12 is 1, it cancels. But I'm also going to raise this side to the 4/3 power. So we'll get 2x equals, so now this is really the cube root of 8 raised to the 4th power. So the cube root of 8 is 2, 2 to the 4th power is 16. So if 2x equals 16, x equals 8. We're going to make sure we check this. So 2 times 8, we have 16 to the 3/4 power plus 2 equals 10. 16 to the 3/4 is 8. So 8 plus 2 equals 10. And that does, in fact, work. So x equals 8 is a solution. Do another one. So in this one, we see it's raised to the 1/2 power. So the reciprocal of 1/2 is 2. So I'm going to raise this to the 2nd power, which means I'm also going to raise that side to the 2nd power. Here these cancel, so I'm left with just x plus 30. And that's going to equal x squared. This is a quadratic. It should be equal to 0 to solve. So I'm going to subtract the x, and I'm going to subtract the 30. So I end up with 0 on this side equals x squared minus x minus 30. All right, we're looking for what multiplies to negative 30 and adds to negative 1. So that looks like it's going to be x minus 6, x plus 5. All right, so if I set these equal to 0, I get x equals positive 6 and x equals negative 5. I'm going to make sure I check both. So this is positive 6 plus 30 raised to the 1/2 power equals 6. So that's 36 to the 1/2 power equals 6. This really means the square root of 36 equals 6. So that's good. Then I'll check my negative 5. So we have negative 5 plus 30 to the 1/2 power equals negative 5. That's 25 to the 1/2 power equals negative 5. But the square root of 25 is really positive 5, not negative 5. So this does not work, right? We can't say that the square root of something is equal to negative 5. All right, you're going to go ahead and give these 3 a try. This is where we'll actually be ending our lesson today. Pause, and then when you're ready, check your answers. All right, so for 7, we should get x equals negative 9. For 8, we should get x equals 3. And for 9, we should get x equals 14. All right, that's it for today's lesson. See you tomorrow.